Hello dear students, my name is Vikas Agarwal and I am going to be your physics teacher for NSEJS series. So guys, in this series I will be covering portions of physics which are relevant for NSEJS 2025, that is, and this entire course will be covered in English. Alright, last year I did a similar course on Vedantu Olympiad school YouTube channel that was in Hindi. This year I am doing the same course but in English. Alright, about my profile, my name is Vikas Agarwal. I have done BTech in Aerospace Engineering from IIT Kharagpur. I graduated in the year 2008 and after that I directly joined the coaching industry. I became a physics teacher. I started my career with FITG, then I moved over to Career Point, then to Mansell classes, then to Resonance, and in 2019 I joined Vedantu. Currently I am the head of topper division at Vedantu. So that's about me. Now let's look at the what we are going to cover in this course. So we'll start with basic maths. So to study physics, we need a certain amount of mathematics. We need the awareness of a certain amount of mathematics. So that I'm going to cover in basic math. Most of the times I will not be giving you proofs. All right, I'll be stating you things. So these are actually mathematical tools. All right, so you will be studying these topics in detail as part of your mathematics course of grade 11th and 12th. All right, but here I will only introduce you to the formulas that we are going to use. All right, because without this it will be difficult to understand the remaining of the topics. We'll not be able to go into the mathematics. Okay, so we'll start with basic maths, then I'll teach you about vectors, then 1D motion, then laws of motion, work per energy, circular motion, system of particles, rotation, gravitation, fluids. So this is going to be our sequence in which we are going to cover the topics. All right, okay, now in basic mathematics what we have to cover, I am highlighting it. So we'll cover parts of trigonometry. We'll talk a few things about coordinate geometry, determinants, functions, differentiation and integration. All right, these two are the ideas which will be totally new to you. Okay, and of course most of these ideas are totally new to you, and I'll just introduce them in a manner so that you understand them, you are able to use them as and when needed. Okay, in trigonometry what are we going to cover? We are going to talk about angles and quadrants, the 6 trigonometric ratios, the table of common angles, the identities, angles greater than 90 degree, sum and difference formula, double angle formula, triangles, inequalities, and triangles, sine rule and cos rule. So these are the things that we have to cover in this chapter. Of course, all of them will not be covered in today's session. Let's see how far we can go in today's session. Okay, in coordinate geometry, this is the things that we are going to cover: marking a point in space, marking a point in 3D space, and slope of a straight line. All right, and determinants, functions, differentiation. So all these things we are going to cover. Learning to differentiate, meaning of differentiation. All right, integration, we will learn the how to integrate and what is the meaning. So all these things may not be becoming very clear right now. Of course you will understand them in detail when we cover them. I'm just telling you what we are going to cover in this chapter. Okay, so let's begin guys. So let's begin. So our first topic was trigonometry, and in that we were supposed to start by angles. Okay, so guys, my first question to all of you: when I say angle, what comes to your mind? Or if you have been introduced to this idea, what can you recall about this? If you have not been introduced to this idea, I will do that now. So I believe all of you will agree with me if I say that this is a circle. Okay, somewhat like a circle. Of course I've done freehand drawing, so it may not be a perfect circle, but it's a good enough circle. Okay, let us draw a line, radius in this circle, and this is going to be a static line. Okay, so we are not going to move. Let's call this as O, and let's call this as A. Okay, here A is the position where, let's say, a particle, okay, some particle was present here at A, and now this particle has traveled along the circle some distance and it has reached a new position, let's say B. Okay, the distance covered by the particle, okay, that let's represent that by S. Okay, so this S is called the arc length. Okay, this S is called the arc length. Okay, OA length is the radius of the circle. Okay, now this angle, this is called the angle. Let's represent it by theta. So the definition of theta is defined as S by R. So S is one kind of length, it is the distance covered. R is another kind of length, it is the radius, so it will again be meter. So S by R, meter divided by meter, this is called the angle. And what we get, whatever number we get here, we report the unit of that is radian. So theta by R, S by R radian. So this is how we define the angle. Okay, this is how the all the discussion around the angle begins. Okay, now the units, okay, units, common units for measurement of angle, okay, they are like degrees, okay, and radians. Okay, I think degree is something that you would be more familiar with. Okay, so I'll tell you that how to convert degree and radian. 180 degree is equals to pi radians. Okay, so if you remember this, then you will be able to convert any angle that is given to you in degree. If you want to convert it into radian, you will be able to do that. And similarly, you can do the other way around also. If any angle is given to you in radian, you will be able to convert it into degrees also. Let me demonstrate how you can do that. Okay, for example, suppose I want to know how much is 45 degree in terms of radian. 45 degree is equals to how many radians. So I will write it like this, that 45 degree, degree is denoted by this small circle at the top. That is the representation of degree. Okay, so I will write 45 degree as 45 times 1 degree. Okay, 1 degree done 45 times, that is 45 degree. Okay, and 1 degree can be written as pi radians. Okay, pi radians by 180. How am I able to say that? See, 180 degree is pi radian, so 1 degree would be pi by 180 radian. Okay, so this will become, this 45 become of like 45 times 4 is 180, so this will become pi by 4 radian. Okay, so 45 degrees pi by 4 radian. Similarly, if I talk about 90 degree, then it will become pi by 2 radian, and so on. So like this you can convert degree into radian. If we have to do the other way around, suppose something is given to me in radians and I want to convert it into degrees. So let's say we have been given pi by 3 radian and now I want to convert it into degrees. So that's very simple. Actually, pi radians can be written as 180 degree. Okay, so pi radian is 180 degree. So 180 degree by 3, that is 60 degree. So like this you can convert degree into radian and radian into degree. So please remember this formula, 180 degree is equals to pi radian. Okay, this is something that should come very naturally to you. Okay, now apart from this, there are few more things that you need to learn. I will write it here only, that 1 degree is equals to 60 minutes. Okay, and 1 minute is equals to 60 seconds. Okay, so remember this, 1 degree is 60 minutes and 1 minute is 60 seconds. So this is when we have to talk about angles which are less than 1 degree, then we talk about minutes and seconds. Okay, so this is about angles. Now let's talk about angles and quadrants. Now what does that mean? So guys, if I ask you that, have you seen this diagram, like this is x-axis, this is y-axis, you would probably say yes, that is my expectation. This is an xy plane. Okay, this is a number line. Okay, this is a number line in which the numbers are increasing as we are moving towards right. This is another number line in which the numbers are increasing as we are moving upward. Usually we call this as x and you call this as y-axis. So this is x-axis, this is y-axis, and this entire plane will be called as the xy plane. That is the usual things that we do. Okay. Now, once you draw these axes on any plane, once you draw x and y axis on any plane, you divide the entire plane into 4 segments or 4 parts. Okay, as we can see here, you have to imagine this line going up to infinity on both sides. You have to imagine this line going into infinity on both sides. Okay, once you imagine that, you would probably agree with me that I have divided this entire plane. Again, you can imagine this plane. All right, this plane, the plane of this screen, you can imagine it to extend up to infinity in the upward direction, infinity in the downward direction, infinity towards left, infinity towards right. So this entire plane has been divided into 4 parts. Each part is called a quadrant. Okay, and we number these quadrants as, this one is called the first quadrant. Okay, this one is called first quadrant. This one is called second quadrant. This one is called second quadrant. This one is called third quadrant. Okay, this one is called third quadrant, and this one is called fourth quadrant. Okay. Now, why are we studying about this? Usually, when we try to mark an angle in the xy plane, if nothing is mentioned, the usual rule is to treat this reference line, you remember this reference line from which we may mark this angle theta. Usually we keep the reference line as the x-axis. Okay, so if I keep the reference line as x-axis and then I draw an angle, okay, if this is my reference line, for example, let's say I want to draw 60 degree. Okay, 60 degree. I hope you agree with me, or you know this already, that this entire angle is 90 degree. Okay, the right angle, we call it as right angle. This is 90 degree. So 60 degree would mean an angle like this. Okay, in other words, 60 degree would end up being in the first quadrant. Okay, we will be required to identify the angle, the quadrant in which an angle falls. So 60 degree falls in the first quadrant. Notice this. Okay, similarly, if I talk about 120 degree, will you be able to tell me that 120 degree falls in which quadrant? Think about this, everyone. Okay, if I ask you to mark 120 degree, okay, then you will probably mark it like this: 90 plus 30. Okay, 90 plus 30, so that would be 120 degree. So would you agree with me that 120 degree falls in the second quadrant? Okay, 120 degree falls in the second quadrant. Now, if you are with me, if you have been able to follow me until now, can you tell me that to get to the third quadrant, what is the angle that we need to cross? What is the value of the angle that we need to cross? Can you tell me, guys? Okay, now if you are suggesting 180 degree, then you are right. Okay, so for example, if I talk about an angle like 210 degree, okay, then you will mark that angle as like 180 plus 30. So this angle will be 30 degree. Okay, this is 180, then 180 plus 30, that will become 210, and we can notice that 210 degree will fall in the third quadrant. Okay, and likewise, if I ask you that what is the angle that we need to cross to reach to the fourth quadrant, okay, you will agree with me that to reach to fourth quadrant we need to have angle more than 270 degree. Okay, for example, something like 300 degree. Okay, so if I want to mark 300 degree, okay, let me choose this color. If I want to mark 300 degree, then it would be 90 degree plus 90 degree, that makes it 180 degree. Okay, so 90 plus 90 plus 90, that makes 270. Okay, and then 30 degree. Okay, so this angle is 30 degree, this angle is 30 degree. So 90 plus 90 plus 90 and then 30. So you will agree with me that the 300 degree angle falls in the fourth quadrant. Now, if you are already troubled by a thought, or if you are already wondering, what about 90 degree? What about 180 degree? What about 270 degree? In which quadrant do they belong? Now guys, you are confused here because you know that they will not belong to any quadrant. Okay, these are the boundaries of the quadrant. So we can't assign any quadrant to these boundaries. So if there is an angle of 90 degree and suppose you have been asked, or suppose you are wondering that which quadrant should I assign to 90 degree, well, it is not belonging to first quadrant, it is not belonging to second quadrant. You can just say that it lies on the y-axis. Similarly, 180 degree lies on the x-axis, 270 degree lies on the y-axis. Can you tell me that what would be the angle that I need to cross to reach first quadrant again after starting it? For example, if this is the coordinate, if this is the xy plane, okay, and I ask you to mark 400 degree, will you be able to tell me the quadrant of 400 degree? Okay, let's try it out, guys. So 90 plus 90 plus 90 plus 90, that's 360 degree. Now if you move 40 degree more, okay, if you move 40 degree more, then you will end up with 400 degrees. So this is 400 degrees, and we can see that 400 degree ends up being in the first quadrant. Okay, I hope till this part we are clear. Now we can talk about negative angles also. So when we talk about negative angles, instead of moving anti-clockwise as we have been doing it, okay, this sense of rotation is called anti-clockwise. So instead of moving anti-clockwise, we then move clockwise. Okay, if we are talking about a negative angle, for example, suppose I ask you to mark minus 60 degree. Can you tell me, students, where minus 60 degree will lie? can you tell me where minus 60 degree will lie? So for minus 60 degree, you will go clockwise by an angle of 60 degree, and therefore minus 60 degree angle will lie in the fourth quadrant. You need not write minus here, you can just draw an arrow in the clockwise direction, so that would indicate that you did not put a plus also. Okay, the clockwise sense will indicate that this is 60 degree in the negative direction. Alright guys, so I hope it is very clear to you that if we have been given an angle, can we find out the quadrant? Let's do an exercise also. Let me give you a question, or let me give you some angles for which you can try to find out the quadrants. Okay, so find quadrants. Okay, so let's say this is question 1. Okay, you can give me your responses in the comments of this session. You know, I'm numbering the question, you can mention the question number and you can give me your responses. So find quadrants of following angles. Okay, so let's say we want to talk about 60 degree. Okay, we want to talk about 2 pi by 3. If nothing is mentioned in the units, understand that we are talking about radians. I am writing it here, but many times it won't be written and you would be expected to understand that it is radians. All right. Minus pi by 3. Okay, again now I'm not writing the radian. Then let's say 2 pi by 5. Okay, then let's say 1020 degree. Okay, let's say 4000 degrees. Okay, use your brain, use your intelligence. Of course, I never went to such high angles with you guys. Okay, but again, this is something that I'm expecting you guys to figure out what to do. All right, if you are intelligent enough, you will figure out yourself that even if I increase 2 more zeros here, that shouldn't bother you too much. You know, you will still be able to get to the answer. Okay, so that's about angles and quadrants. So till now we have learned about the angles, we have learned about identifying the quadrant in which a given angle will fall. Okay, let's now talk about the 6 trigonometric ratios. T ratio means trigonometric ratios. So let's say this is a right angle triangle. So this angle is 90 degree. Let's represent this angle by the symbol theta. So once you do that, once you mark this angle theta, so for this angle, all right, this particular length, you know, the length opposite to this theta, like if this is 90 degree, then this is called the hypotenuse. The longest side of a right angle triangle is called hypotenuse. Okay, I think you know that because you should be aware of the Pythagoras theorem. Okay, this is called the perpendicular, this is called the base, and from Pythagoras theorem we know that h square will be equal to p square plus b square. So this is Pythagoras theorem. Okay, now we define something called as sine theta. All right, we write it as sine, we call sin, sine theta. We can put bracket also if you want. Okay, you can write without bracket also, you can put bracket also, that's up to you. Okay, for beginners I suggest the use of brackets. Okay, but when you have become skilled enough, when you have become comfortable enough, then you can stop using the brackets. When you will see teachers and your seniors doing maths in front of you, they will probably not be using the brackets, but as beginners you should use the bracket, because even when I am writing this, mentally I am aware that there are brackets here. So then if it is so essential to use the brackets, then why do the people who become very well versed in these kind of things, why do they stop using the bracket? Well, it's an added effort to draw. It makes the expression cumbersome also, it makes the expression heavy also. So but yeah, you should use it right now. So sine theta is defined as perpendicular upon hypotenuse. So that is the ratio, and because hypotenuse is the longest side of the triangle, this ratio will always be less than 1. You can, although that would not be the best of explanations here, because you will learn in mathematics that sine theta can attain negative values as well. So from triangle I can't explain how it can assume the negative value. For but let's not, we'll not go into that direction. Your maths teacher will be doing that explanation when you study trigonometry formally. Okay, right now we are studying with the perspective of using trigonometry when we need it. Okay, so sin theta is this. The other trigonometric ratio is cos theta, which is defined as base upon hypotenuse, and the third trigonometric ratio is tan theta, which is perpendicular upon base, which can also be written as, you can check it, sin theta by cos theta. If you take this ratio, if you divide sin theta by cos theta, you will get perpendicular upon base. Okay, so these three are the most common ones. Okay, these three are the more common ones. There are, when I say common, I mean that generally academicians try to write the expression in terms of sine, cos or tan only. Okay, but there are three other ratios also. All right, and they are the inverse of these three. So the inverse of sine theta is called cosec theta, C-O-S-E-C, cosec theta. Okay, similarly inverse of cos theta is called sec theta, and inverse of tan theta is called cot theta. Okay, it's called cot theta. So these are the three other trigonometric ratios. So the total 6 trigonometric ratios are sine, cos, tan, and then cosec, sec and cot. We will need only these three to work with, because anything that we want to do, we'll be able to do using these three trigonometric ratios. Okay, now what does this actually means, like sine theta? So basically, if I provide a value of this angle, for example sine 10 degree, sine 20 degree, sine 30 degree, so these represents a fixed number. Okay, so sine 1 degree would be a specific number, sine 2 degree would be a specific number, sine 3 degree would be a specific number, and so on. We can also talk about sine 1.5 degree, sine 2.5 degree, or 2.6 degree, or 2.7 degree. Okay. And there are charts available. There are charts available which we call as trigonometric tables, which list down the value of these things. Like from a trigonometric table, there are charts available in the form of small books. You can note, like you can see the value of sine 1 degree, or sine 1.1 degree, or sine 1.2 degree, and so on. Okay, so the point here is that when you put an angle here, then it starts representing a particular number. We don't know that number. Like when we say we, I mean any individual may not have memorized that number, but they are available in the form of tables. So we can refer the tables and we can find out those numbers. Okay, or all that information is also present in your scientific calculator. So in a scientific calculator, if you punch sine of 25 degree, then your calculator will tell you the value of sine 25 degree. Or if you ask your scientific calculator to give you the value of cos 45 degree, it will give you the value of cos 45 degree. So the whole idea that I'm trying to convey here is that sine of a certain angle is a fixed value, okay, which is listed somewhere in books. We can refer to them when needed, or which is also stored. The same information is also stored in your scientific calculators. Okay, when the scientific calculators were not there, people used to refer to those books. Now, who wrote those books? Of course, the mathematicians did they did a laborious task of finding out the value of sine of every angle and cos of, and that they can do that. Like you will learn that it is quite possible to do it once you learn all these things in mathematics. But for now, the entire idea that I'm trying to drive into your brain is that when you put an angle in front of these ratios, they start representing numbers which we may not know, all right, but someone knows, and that has been put down in a list, and that list is available for everyone to see. Or the same list has been stored in your scientific calculator also, so you can make use of scientific calculator also. Okay, but we can't remain so naive. All right, we can't say that every time we need something we will refer to the tables or we will make use of the scientific calculator. So what we do, we have identified certain very common angles, okay, that are used in most of the questions that we are going to see in physics. Okay, so what we have done, that the most common angles that we are going to come across every now and then, we will learn the value of sine, cos and tan for those specific angles. All right, so that every time we need the sign of common angle, we don't have to rush to get the table, or we don't have to rush to get the scientific calculator. Okay, so that's the whole idea. So let's move to that now. So what are the common angles? Okay, the most common angles are 0 degree. Of course you can write it in radian also. I'll stick to degrees. So 0 degree, 30 degree, 37 degrees, another very popular angle that is used in physics. Okay, 45 degree, 53 degree. Notice for 53 and 37 they are complementary angles. That means their sum will become 90 degree. Okay, 60 degree and 90 degree. So these are the most common angles that are used in making questions in physics and also in mathematics. So we will learn the value of sine, cos, tan for all these angles. So I've already learned it, of course, so I will mention it here and you guys have to learn it. Okay, and there are tricks. There are tricks to learn this table. Okay, I'm not telling you any trick right now. I will ask you to just go and do Google search, find a good video to learn these tricks. Okay, I'm telling you the value right now because my agenda is to populate this table with the right numbers. So sine 0 is 0, sine 30 is half or 0.5. Okay, sine 37, almost 37. Okay, the sine is, it's 3 by 5. Sine 45 is 1 upon root 2. Sine 53 degree is 4 by 5. Okay, sine 60 is root 3 by 2. Sine 90 degree is 1. Okay, so these are the numbers. Now I said that if you want to learn these numbers, go and look for tricks in YouTube. So there are tricks actually. I'm not diverting right now and therefore I'm not telling any trick to you. But there's one small thing that I can tell you. Whatever numbers you have filled in here, you can just reverse them here. So cos 0 would be 1. Okay, cos 30 would be sine 60, that is root 3 by 2. This would be 4 by 5. This would be 1 upon root 2. This would be 3 by 5. Okay, this would be half and this would be 0. Okay, now why did I do this? Because I'll tell you a formula. Here I mentioned the common trigonometric ratios. There are some relation also between them, which is very evident from here. See, if this angle is theta, then this angle will become 90 minus theta. Suppose I am writing sine theta. So sine theta would be perpendicular upon height, hypotenuse. Now notice that if I would write cos of 90 minus theta, so for this angle, okay, this becomes base. Okay, this becomes base and this becomes hypotenuse, which means that, see, P by H, P by H. So sine theta is equals to cos of 90 minus theta. So there exists some relationships also among them, and using this relationship I have written that. Okay, so the common relationships are sine theta is same as cos of 90 minus theta, or the second one is that cos theta is same as sine of 90 minus theta. You have to learn this, everyone. Okay, you have to learn this. So sine theta is same as cos of 90 minus theta, cos theta is same as sine of 90 minus theta. Okay, so therefore what we can say that if you change this angle with 90 minus theta, then the same becomes cos. So that is what is happening here. Sine 30 is same as cos 60. That's what I'm trying to highlight. Getting it? Sine of any angle and cos of the complementary angle, they are equal. Okay, and now to find out tan x, you can just keep on taking the ratio. So tan x would be 0 by 1, that is 0. The ratio here will become 1 upon root 3. Okay, the ratio here will become 3 by 4. Here it will become 1. Here it will become 4 by 3. Here it will become root 3. And here it will become not defined, because 1 upon 0 is what we are going to get. So you can either write not defined or you can write infinite. Okay, so this is the table. I'll get off from the frame so you can capture this table. You have to note it down in your notes copy, and you have to learn it, everyone. Okay, so that is the table for common angles. Now what are trigonometric identities? So identities means relations which are always true. Okay, so there are some trigonometrical identities that I want you guys to learn, and those are this. Like the first one is sine square theta plus cos square theta is 1. So that is one trigonometric identity. Okay, then 1 plus tan square theta is equals to sec square theta. Okay, then actually from this it is very easy to get this. I'll tell you how. In this equation you divide the entire equation by cos square theta. Okay, if I divide the left hand side and the right hand side by cos square theta, see, our job is done. Okay, so this would be this will become tan square theta. You can check sine square upon cos square plus 1 is equals to, this is sec square theta. All right, so if we accept this, it is very easy to derive this. Similarly, instead of dividing by cos square theta, if you choose to divide by sine square theta, can you tell me what identity you will end up with? In the first equation, instead of dividing by cos square theta, if you divide it by sine square theta, you will end up writing 1 plus cot square theta is equals to cosec square theta. Okay, so remember them. Why do you need this? I'll tell you. Like, let me give you an example. Suppose if I tell you, like, if sine of, let's say, theta is given to be 2 by 3, okay, then find cos x or cos theta. Okay, then how can you do it? You will say, okay, sine square theta plus cos square theta is 1. So 2 by 3, that is sine theta is given to be 2 by 3. So 2 by 3 square plus cos square theta will be 1, which means cos square theta will be equal to 1 minus 4 by 9. Okay, so it will become 5 by 9. Okay, and therefore cos theta will become plus minus root of 5 by 9. All right, so like this, if you have sine theta, you'll be able to find out the value of cos theta. Similar things can be done with tan, cot and others. So these are trigonometric identities. You need to remember those. There are others also, but I'm telling you the bare minimum that you need to know at this point, okay, to become efficient in physics. All right, now angles greater than 90. Okay, so what I'm trying to say, in this table we have learnt the value of sine, cos and tan of the common angles, and common angles till 90 I have taken. What if the angle is more than 90? Can we do something about it? So guys, we can actually use this table to deal with certain angles, not saying all the angles, but to deal with certain angles which are more than 90 and which are somehow related to these angles. What do I mean by that, somehow related? I'll explain that. So let's say I want to know sine of 120 degree. Now that is beyond my table, but 120 degree is what? 90 plus 30. 90 is the standard angle, 30 is the standard angle. Okay. Okay. Or let's say I want to talk about tan of 300 degree. Okay. So can we do something about them? Okay. So guys, there is actually a way. We can actually find them out, and to find this out there is a set of rules that we have to follow. So I'm going to tell you those rules. While I'm explaining, it may appear like the rules are very cumbersome or there are too many things, but once you start executing them, like once you understand the rules and you start doing them yourself, you will find that they are actually pretty easy. Okay, so let's start doing it. So I'll mention the rules here. Okay, so the first rule is the ASTC rule. Okay, that you have to keep in mind. So what is ASTC rule? So this is like, to remember the sequence ASTC, these are the 4 quadrants. Okay, let's say this is the x-axis, this is the y-axis. Okay, so write ASTC. To remember it, you can remember this statement: add sugar to coffee. So that will help you to remember ASTC. Okay. A indicates that all trigonometric ratios are positive in this quadrant. A represents all trigonometric ratio, whether it is sine, cos, tan. Alright, if an angle falls in this quadrant, we have seen that angles can fall in different quadrant. Okay, so if an angle falls in first quadrant, then all trigonometric ratios are going to be positive. Okay, in the second quadrant, S, so sine and inverse of sine, that is cosec. I'm not talking about inverses right now, so let's just worry about sine, cos and tan. So sine will be positive in the second quadrant. So if an angle falls in the second quadrant, then its sine will be positive, but its cos and its tan will be negative. Okay, so in second quadrant, sine is positive. In third quadrant, tan is positive and sine and cos are negative. So if an angle falls in the third quadrant, then its sine would be negative, its cos would be negative, but its tan would be positive. And if an angle falls in the fourth quadrant, then its cos would be positive, but its sine and its tan would be negative. Okay, so the first thing that you have to keep in mind is that we are going to make use of the ASTC rule. Okay, so to use this rule, we need to identify the quadrant of the angle. Okay, so identify quadrant. Okay, so for example, let's do this. 300 degree. Can you tell me, guys, where 300 degree will lie? We are going to find out the value of tan 300. So can you tell me 300 degree, if I try to mark it, where will it lie? 300 degree would be 180 plus 90, 270, and then, so this is going to be 300 degree. So 300 degree will lie in the fourth quadrant. Okay, so we have identified the quadrant. Okay, so identify the quadrant, and in this process also notice the acute angle made with x-axis. Okay, what does that mean? See, we have marked 300 degree. Now what is the acute angle made with the x-axis? So this would be it, notice. And if this is 300, then this is bound to be 60 degree. Let's call it alpha for now. So once you have identified, so let's call it alpha. Let me write it as, let's call it alpha. Okay, alpha. Okay, so identify the quadrant. Then third step, what you have to do, okay, whatever T ratio, for example, we are currently working with tan, so T ratio theta that you have to find. So sine, write the sine using the ASTC rule, keep the same T ratio and write alpha. Okay, that's it, you're done. Okay, let's do it. So tan 300, it falls in the fourth quadrant. In fourth quadrant, tan is negative. So according to the ASTC rule, the sign is negative. Like the tan 300 falls in the fourth quadrant. In fourth quadrant, cos is positive, tan is negative. So I put the negative sign here. Then I copied the same trigonometric ratio, tan, and alpha is 60 degree. Now, do we know the value of tan 60 degree? Well, yes, we did remember the value of tan 60 degree, that was root 3. Okay, so you can now substitute that value here. So minus root 3 will be the answer. So we were able to find out the value of tan 300 using the rules. Now I would suggest that you guys try for sine 120 degree. So if I check that in which quadrant 120 degree will lie, what will you say? 120 degree. So 90 plus 30. So 120 degree will lie in the second quadrant, and the acute angle made with the x-axis will be, this will be 60 degree. So alpha is 60 degree. Okay, so in second quadrant, sine is positive. Second quadrant, sine is positive. Okay, so plus sign, the same trigonometric ratio, then alpha, which is 60 degree. So it would be plus root 3 by 2. From where did the root 3 by 2 came? Sine 60 is root 3 by 2. We have written it in the table. Sine 60 is root 3 by 2. Okay. So from here I have put the value. So like this you can figure out the value of any angle which is more than 90 degree. Okay. To practice a few, let me give you, alright. So that would be my second question. Okay. Find the values of following. I'll give you angles which ultimately, like angles for which alpha is from this table itself. I'll give you questions so that you can use this table. Okay, you don't have to rush to get the trigonometric charts. Okay, so you can start by calculating tan of minus 60 degree. Okay, use your brain. Okay, cos of 5 pi by 3, again use your brain everyone. I'm deliberately giving you tough questions. Okay, sine of let's say 390 degree. Okay, then tan of 5 pi by 4. Okay, then cos plus 480 degree. So that should be enough. Okay, so try them out. You have to find the value of now whatever I have taught you, using that we can actually make some more rules. Like we can make rules for negative angles. We can, of course you don't need it. Okay, if you have learned this trick, you know, whatever I have taught you here, if you have learned this, then what I'm going to tell you now, you don't need it. You can figure it out. Okay, but you will see this as standard formula when you start learning mathematics. So this is, you know, you're not needed. Okay, this is not needed. I'm just trying to help you with something that you will come across. For example, sine of minus theta is how much? Okay, so if I go by the same rule, okay, I'm assuming that, okay, theta, let theta be an acute angle. So minus theta would mean that we will end up in the fourth quadrant. In fourth quadrant, sine is negative and the acute angle will be theta itself. So alpha is theta right now. So sine of minus theta is minus sine theta. Let's try the same thing with cos of minus theta. So cos of minus theta we already know is in the fourth quadrant. In fourth quadrant, cos is positive. So plus cos theta. What about tan of minus theta? So in fourth quadrant, tan is negative. So minus tan theta. Got this everyone? What about 90 plus theta cases? For example, I want to know sine of 90 plus theta. Now what? Okay, so 90 plus theta will end up in which quadrant? Let's see. 90 plus theta will end up in the second quadrant. This angle is 90 degree. Okay, and then this angle is theta. Okay, so the acute angle with x-axis will become 90 minus theta. So the alpha angle that we were talking about is now, so in second quadrant sine is positive, so plus sine alpha is 90 minus theta, and sine 90 minus theta we wrote at the right at the start we wrote sine 90 minus theta is cos theta. So we can invoke this. Okay, so it will become plus cos theta. Okay, similarly, what about cos 90 plus theta? So we already know that 90 plus theta is in the second quadrant. In second quadrant, cos is negative. So minus cos alpha is 90 minus theta. So 90 minus theta. Cos 90 minus theta is sine theta. Okay, got this? So like this, you can work with 90 plus theta cases. Alright guys, so for today, I think that's here where we stop. I will share an assignment also guys. In the description of this session, you will find a PDF link, and that is the link to the assignment. Okay, so after watching this session, you should be able to do that assignment. Definitely try it out before you watch the next session. Otherwise, you may have difficulty understanding the next session. Alright students, take care. I'll see you in the next session. Take care everyone. Bye-bye and happy learning.